All right, we are going to factor today. We're going to factor quadratics. We're going to do it two different ways. We're going to either have our a value equal to 1 or our a value not equal to 1. Before we get into factoring, though, we are going to remember how to multiply. So we did do this yesterday, but let's do it again. Go ahead and do your warm-up of x plus 3 times x plus 2, and do x minus 1 and x plus 5. So do that real quick and check with your partner and see if they're the same thing. How did we answer the first one? What you got for me? Yes, ma'am. X squared plus 5x plus 6. Beautiful. Who has it for part B? Yes, ma'am.
X squared plus 4x minus 5.
Plus 4x minus 5. Go. We remember how to FOIL? Yes. FOILing is multiplying. So what do you think factoring is? Unfoiling or dividing. Yes, it's a way to break apart quadratics, so to put it back in factored form. Okay, we did factored form yesterday, where we had the value on the outside, and then we had our two factors. This is what we used on your homework last night to try to solve and find A and all that good stuff. Okay, so we want to put it back into that format. There were two ways you learned algebra 2. There's basic factoring when you have just an x squared at the beginning, meaning there's a 1 out front technically. And then there's ways when something else is out front. There's a 2, there's a 5, there's a 7. Something else is leading the quadratic equation. Okay? So we're going to remember our basic factoring first. To do that, look at your warm-up. Okay? How do 3 and 2 relate to 5? How does 3 and 2 relate to 6? What you think?
3 and 2, you add this, you get 5, when you multiply this.
Right, nice. When you add them, you got 5. When you multiply them, you get 6. Does that happen again for part B? With negative 1 and 5? If you add those, do you get 4? If you multiply them, do you get negative 5? Yes, keep that thought process going. That's what we're going to use to work backwards. So if I have x squared plus 9x plus 20, something had to add to give me 9, and then the same things had to multiply and give me 20. What do you think it is? What kind of a 4 and what kind of a 5? Both positive. Good. So because that last piece was a positive 20, okay, that gives you a hint that they have to both be positive or both be negative, right? If I multiply to get a positive number, they got to both be the same thing. All right, over here. X squared minus 7x minus 60. So this time we are multiplying to get negative 7. I'm sorry. We are adding to get negative 7, but we're multiplying to get negative 60. Yes, Jordan. Negative 12, positive 5. Okay. If you're ever not sure, make your list of factors for 60. So you know we have 1 and 60. There is 2 and 30. 3 and 20, 4 and 15, 5 and 12, 6 and 10. If you're ever stuck, you can start by making your list of factors on the end. And then, okay, which one of these could somehow give me a 7? 5 and 12 could give me 7 somehow, right? I want negative 7. So do I want 5 minus 12 or do I want 12 minus 5? We want positive 5, yeah, and then the negative 12 to get to my negative 7. All right, so if you ever get stuck, that's kind of the thought process you should go through. All right, here, my last number was negative, right? Negative 60. So I know that my signs had to be two opposite signs. Only way to get negative is with a positive and a negative to get there. All right, you good? Okay. Oops. Okay, so let's go down here. Now we have x squared minus 10x plus 21. What you think, Savannah? Negative 7, negative 3? Does that make sense? Is negative 7 plus negative 3 negative 10? Yeah. Is negative 7 times negative 3 positive 21? Yes, it is. All right, well, what's going on with the next one? That is not a 1. That is a 5. Yes. Over here it says watch out for GCF. What does GCF mean? Greatest common factor. Here I can divide each term, and it has to be each term can be divisible by that 5. Does that mean 5 just disappears? No, it's just going to be in front of everything, okay? So what is in my parentheses now? Minus 14. Yep. Now can you factor the trinomial? Yes. Do you know what a trinomial is? Some of you gave me a weird look. 3 pieces. So what multiplies to give me negative 14 but adds to give me a positive 5? 7 and 2. What kind of a 7? What kind of a 2? Positive 7, negative 2. Good. And what should still be out here? The 5. Okay. The first step that we did when we factored out the 5, you're doing opposite of distribution. You took it out of each piece. Okay. And then we factored or divided, broke apart our trinomial.
So the last part is the final answer.
Yes, the last part is the final answer. Okay. What about this guy? Good. It's not by itself. Technically, it's a what? A negative 1. So we're going to divide each piece by negative 1. So we have negative 1 times what? There you go. Yep. Can I factor that? Yeah. What multiplies to give me 2 but adds to give me 3? 1 and 2. Good. Cool. Does the next one look familiar? Yeah, I know. That was a typo. I'm going to change it. We already did this one. Did you just do it again? Did you get it right? Okay. Good. I would be concerned if you didn't. We're going to change this. So it's going to be 3x squared minus 6x and then minus 72. So you work on that one. What should I do first? Can you divide them all by 3? Yes, they are all divisible by 3.
Oh, I'm sorry.
Little foreshadowing there. So now what's left in my parentheses? What do we have? X squared what? Minus what? 24. Yep. What multiplies to give you negative 24 but adds to give you negative 2? Negative 6 and positive 4. Yep, so because it was negative 24, they had to be opposite signs. It's all good. Good job. So are we doing basic factoring? Is it coming back? Yes? Okay. All right, so Hannah asked a great question. What if you can't divide it out? Okay, we are going to do something called slip and slide. Different teachers call this different things. Miss Chen calls it the cloud method. Hannah, what'd you call it? Slide, divide, bottoms up. Same concept, okay? Some teachers do guess and check. Some teachers do like a box method. Lots of different ways to do this. I personally like slip and slide. So I'm going to show you my way. What we should always do, just because there's a number out front does not mean you have to do slip and slide. Okay? Because what should we always look for? Yes, you should always look for your greatest common factor first. Okay? You should always look for that first. Because if I can divide it out like the ones before, then we don't have to slip and slide. All right? What we are going to do, so if we don't have a GCF, if we cannot divide it out, we're going to slip A to the end and multiply it by c. What am I talking about? Our standard form is ax squared plus bx plus c. When I'm talking about a's and c's and stuff, that's what I'm talking about. Yep, so you're going to take that first piece and you're going to multiply it to the end. Like that. Okay? Because once you slip it to the end, now you have just an x squared. Then you factor as normal. Then we have to slide or divide that piece back out of my factors. And then we're going to simplify our factored form, which is where the bottoms up part. I don't know, but you shouldn't have to do that.
I shouldn't have to.
Nope. No, it's not.
No? Yeah, 18 times.
Nope.
Oh, because you got it.
Uh-huh. That's what happens when you get work ahead of me. So our first one is 2x squared plus 5x plus 3. So we have a 2 out front. Can I divide 2, 5, and 3 by 2? No. You cannot divide 2. Okay, you cannot nicely divide 2 out of 2, 5, and 3. Okay? So instead, we're going to slip and slide. Take our a value, slip it to the end. Okay? So this is the slip. Now we have x squared plus 5x plus 6. Okay? We can basic factor this one. So multiplies to give us 6, but adds to give us 5. But they have to both be positive. To multiply to give you 6, and add to give you 5, 3 and 2. Careful. Okay, so it's x plus 3 and x plus 2. Okay? Nope. It's not it. Because look, if I stopped right there, I try to FOIL that back through, is x times x 2x squared? No, x times x is x squared, right? So we're not done. We haven't done the slide part. Now we have to slide 2 back out. Slide, divide. Divide each piece by that a value. Right? Does 3 over 2 simplify?
Yes.
Into a whole number? No, it does not. This is the bottoms up part that Hannah was talking about. I say that 2 gets promoted. 2 gets promoted, it gets to move up front. 2x plus 3. Over here, what's 2 divided by 2? 1.
Oh, okay.
And that's it. That's it. Yep. Okay. It's the exact same thing. It's the exact same thing. Okay? If you're not sure if you're done, you can always FOIL. 2x times x is 2x squared. 2x times 1, 3 times x, 3 times 1. I'm just checking my answer. You don't have to do this. I'm just checking my answer. Put those together. I have 2x squared plus 5x plus 3, which is what we started off with. So you can always FOIL the end. Yeah, that's just the way to check. Okay? I just multiplied them together. Yep. All right, so 5m squared minus 17m plus 6. Can you divide each piece by 5? No. So what do I have to do? Slide. Yeah, because careful. We are slipping my 5 to the end. Yes, slip and then slide. If we're going to slip it to the end, what am I working with now? Plus 30. Yep. Now, that multiplies to give me 30. That adds to give me, there you go, negative 15 and negative 2. Does order matter, by the way? I said 15 and 2, but I wrote 2 and 15 because my brain's not connected, I guess. Does it matter, though? No, order. We're good. We're multiplying. Am I done? Should I circle it? No, because m times m is just m squared, right? So, we're not done. What do I have to do? We have to divide. We've done the slip. Now we have to slide.
is that? Like,
You should slip and slide the same number. So since I slipped 5 to the end, now I'm going to slide 5 out. Yes. You're essentially undoing what you did, right? You multiplied and now we're dividing is what we're doing. All right. Does 2 over 5 simplify? No. So 5 gets promoted. It's going to leave this binomial, 5n minus 2. Does negative 15 over 5 simplify? To what? To 3.
it's like a fraction. If the fraction was like negative 4 over 10.
Mm-hmm. And then do bottom. Right. Hold on. Give it a second. Give it a second. It's working. It's working something now. All right. Y'all try the next one. It's on your paper. 6y squared minus 5y minus 4. Try that one. Someone give me number 1 through 28. 4. Soraya. What should we do first? Before that, it was a trick question. What should you check before you split the 6? Yeah, see if it's a GCF. Can we divide this by 6? No. Now what do we do? Yeah. Here we go. So 6 is going to get slipped to the end. So Soraya, what are we working with now?
X squared minus 5y minus 24.
There you go. Give me my next number. 1 through 28. 17. Elena.
What?
Yep. Now what? What? Now what?
Ask a question. Okay, then you see you divide by 4, right? No?
We have y squared minus 5y minus 24.
No, the brain's got the factor thing.
We're going to factor it. What multiplies to give negative 24 and adds to give negative 8? Let's see. We have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which one of those pairs could give me 24? Well, all of them. Which one of those pairs could give me a 5 somehow?
Me?
Yeah, you. This is your question. 8 and 3 somehow.
I said that earlier.
Okay. What kind of an 8 and what kind of a 3? Because it's negative 24, I know that one has to be positive, one has to be negative. So which one's which? Do I want 8 minus 3 or do I want 3 minus 3? To get negative 5. Look in the middle.
Oh, then you would do 3 minus 8.
Yes. There you go. All right, pick a number.
Me?
Yep.
4. Nope. No. 26.
Brody. Now what?
Divide by 6.
Yes, divide both pieces by 6. So, Brody, how does the first one simplify? How does 3 over 6 simplify?
I don't know.
3 over 6, like adds a fraction. 1 over 2, there you go. And then how does the next one simplify? 8 over 6.
6.
1/3, 2/3.
Hold on. 8 over 6. They're both even numbers. 4 over 3. Yes. All right. Give me a new number, Brody.
Don't pick 7.
7. 7. Calicia, is this my final answer? I am talking to Calicia. Is this our final answer? No, wait a minute. That's the very last step. We don't leave my fractions. Look at the one right above it. See how I had 3 over 2? Right? We didn't leave it as 3. We didn't leave it like this. What happened? We brought the 2 up. Right? Okay, so if I have 1 over 2, what's going to happen with that 2? I am at y plus 1 over 2. I cannot leave it that way because right now y times y is not 6y squared. That's how we know we're not done. So 1 over 2, what do I have to do with this 2? I have to move it to the front of my parentheses, like that. Okay, it gets promoted, it gets moved up. So what am I going to do with the other factor? The same thing, but with my 3.
So, wait, what was the rule? You have to promote it if it doesn't do what?
So once you've simplified your fraction, if it's still a fraction, your denominator gets promoted to the front. Okay, because now 2y times 3y, does that give me the 6y squared from the beginning? Yes, so that's why it happens. You have to push them up so you can get that coefficient.
Does it matter if you do like the 3y minus 4 squares?
No, it doesn't matter. Yes, ma'am. Yes. Yep. Yep. Okay. Can we try another one on our own? Yes. Can we try 3x squared minus x minus 10? Okay. You try that one. Stratton. What should we do first? Before that.
Make sure nothing.
There you go. Make sure you can't divide anything out, and we can't. So now what do we do? Split the 3. So what do I have? Yep. All right, give me a number.
14.
Ryan. Now what? Uh-huh. So we need to think what multiplies to give me negative 30, that adds to give me negative 1. Yes, good. Give me a number, Ryan. 20. Kamaya. Now what? Not anymore.
You divide each thing by 3. So, yeah.
Okay, so what does that do?
Oh, so x minus 2 and then, so other one, don't you bring the 3 in the front?
Uh-huh.
3x plus 5.
Yeah, there we go. Are we done?
Yeah.
Yes, yes, we are. Is x times 3x 3x squared?
Yeah.
Yeah, that's how you can kind of check yourself, see if you're done or not.
That's right.
Okay?
Wait, what is this? Why do I 3? Oh, no.
All right. This guy. Are we going to do 3 times 120?
No, we can divide it.
Yeah, we're not going to do that. See why it's important to check? You do not want to make a list of factors that multiply to give you 360 but add to give you 42. That's not fun. Okay? Too much. Instead, there is a GCF. They can all be divided by what? They can all be divided by 3. So now we have what left inside? We have x squared, then what? What's the middle? And what's the end? 40. Is this a slip and slide problem? No, this is not a slip and slide problem. This is just a basic factor problem, but it had a GCF. So now, what multiplies to give you 40, but adds to give you 14?
Oh, that's not the
Do you have to slide? Do you have to divide anything?
So positive 10, positive 4.
Yep,
Oh, you already did it.
I did. That's okay. You were in the zone. Nope, it's fine. Okay, so this is why it's important to check if you have a GCF, because if you do, like the one we just did, sometimes it becomes just a basic factor problem. Okay, or like Hannah gave away. Here we have 18x squared plus 6x minus 12. Do I have a GCF? Yeah, we have a GCF. It's not 3. Careful. It is 6, okay? But is that going to leave me with just an x squared in the beginning? No. but it does reduce it. Yeah, 3x squared, keep going,
That's what it's
6.
plus x, because they're all divisible by 6. 18, 6, and 12. So the n becomes what? -2. Is this still a slip and slide problem? Yes, this one is still slip and slide. But am I going to use my 6 at all for anything?
Yes.
Just in my answer. But like with the slip and slide process, you're not going to touch the 6. Okay, 6 is just hanging out. Here we go. So tell me what to do.
So now, look at
Slip what? What is it? Slip 3,
why 3?
because that's my a value.
So now it's x squared plus x minus 6.
Mm-hmm.
Wait, what did I do wrong? Then, wait, factor it, so it's x plus 3 and x minus 2. Huh? Oh, okay.
So my final answer?
You gotta multiply 3 times 6. Because
What?
multiply 3, you don't have 6, right?
Nope.
Wouldn't it be on the outside?
No, you do the.
What do you do with the 3?
Is it 3? Is it 3 divided by 6?
Oh, I'm sorry, yeah. Side, bottoms up.
So we're going to divide each piece by the 6. That's what we did the slip with. So 3 over 6 simplifies to 1/2, which becomes, yes, 2x plus 1. You're right. What's this one going to be, though? X minus 1/3. So that factor is going to be
It's 3 minus 1.
3x minus 1. And again, how can I check myself? I can do 6 times 2 times 3. That does give me the 18 from the very beginning.
Wait, I'm confused. Why are you dividing by 6? Why don't you divide by 3?
Oh, no. Hold on. Hold your horses. Yes, yeah, back it up. Back it up. You're right. You're right. Yeah, because that did not equal 18, did it? Nope. Okay, kids, here we go. 3 over 3 is 1. Mm-hmm. Okay, yeah, because what did we slip? We slipped the 3, so we should divide the 3. Yes. Slip 3, slide 3. Yep, you're right. For those of you watching the video, mistakes happen. It's important to just catch it and fix it. All right, 3 over 3 is 1, right? 2 over 3 is just going to be 2 over 3. I don't need all this. That does not simplify, so it becomes 3x minus 2. 6 times x times 3x, that gives us 18x squared. Thank you for catching the mistake. That's what happens when we rush through things. We got it, though. Good job. So you do have that worksheet. You have 6 basic factoring, and you have 6 slip and slides. Okay, so you got 12 problems to do.